In today's section, we are going to perform amplitude modulation and demodulation of an analog signal. For that, we have digital oscilloscope, which is 20 megahertz, and we have amplitude modulation and demodulation trainer kit, which is based on the LM1496 DIP IC integrated circuit. And for the demodulation, the diode and one diode is used, which is special purpose diode. The modulation is the process in which some property of high frequency wave, also called as carrier wave, is altered in such a way by low frequency information signal called as modulating wave. In another way, we can tell that amplitude modulation is the process of modulating massive signal superimposed with carrier signal. The high frequency carrier signal is superimposed with massive signal, and which is transmitted through the communication channel. And at the demodulation section, we can detect envelope of the modulated massive signal, and so we will find the massive signal. So first of all, let's check the carrier frequency of this signal. For that, 3.5 mm probe is connected to the ground of the digital oscilloscope, and the second part, the carrier oscillated output of the circuit is given to the oscilloscope. So let's press the auto button. So let's check the frequency. Measure. So we can see here the frequency range is 458.7 kilohertz frequency, and voltage peak to peak is 2 volt. This trainer kit this trainer kit has inbuilt frequency sine carrier wave generator, which is sine wave in this trainer kit of frequency 450 kilohertz of range, and the voltage is for 2.5 volts peak to peak, which you can see here. The frequency range is 450 kilohertz to 460 kilohertz, and the voltage peak to peak is 2.46 volt. And the fixed DC output regulated power supply of 12 volt is inbuilt in this trainer kit, and the built-in audio frequency function generator of 1 kilohertz 1.5 peak to peak amplitude, which is also known as massive signal in this modulation and demodulation kit. So let's check the modulated output first. For that, I'm going to disconnect this probe and connect it to the amplitude modulation output. Connect carrier oscillator output to the carrier input of the modulated signal, and the AF signal output is connected to the AF signal input of this trainer kit, and the ground is internally connected. We should not connect it by using wire. So let's press auto button of the DCRO and slightly start to increase the amplitude of the massive signal. In amplitude modulation, the modulation depends on the modulation index. When the modulation index equal to 1, that situation is called perfect modulation. When the modulation index is greater than 1, uh, that situation is known as overmodulation. And when the modulation index is less than 1, that situation is known as undermodulation. So let's scale our frequency to see modulated signal. I'm slightly changing the amplitude, slightly changing the amplitude of the message signal. And the here you can see when the amplitude varies continuously. Uh, let's stop here and let's scale it and see in this. This is the condition of modulated wave modulation, or you can tell it by under modulation also. When I slightly keep increasing the amplitude of the message signal, it tends to go to the situation of perfect modulation. Let's scale it to the small. Okay, so just we're going to fast list. Stop and scale it. We can see this is the modulated process, and let's magnify it, and then we'll see that it is we can call this as a modulated process, perfect modulation process. When I keep increasing the amplitude of the message signal, then the over modulation case is slightly introduced. Here we can see the over modulation process. Okay, this is the case of over modulation, where modulation index is greater than 1. We can perfectly see it. Okay, let's stop it and scale it. You can see there is a over modulation of the message signal. Okay. Okay, this is the case of over modulation. Now let's modulate this frequency over the amplitude modulation and connect this output to the amplitude modulation input, and let's detect the original message signal, which is passed through the amplitude modulation signal. For this, I will change this. First of all, I will put this here without capacitor in the demodulation section first, and then in the next part we will see the output with capacitor. Let's connect the modulated carrier wave and the message wave to the demodulation section. So we have already started to see the demodulation process. Let's scale it, run and stop. You can see. Okay. Let's decrease the amplitude of the message signal slightly. slightly and slowly. Uh, Slightly and slowly by decreasing the message signal, amplitude of the message signal. You can see the demodulated output. At the first, the amplitude of the message signal, input signal, is 0. There is no message signal over the circuit. Though there is no message signal input in the modulation portion. Let's when I start to give message signal, or when I start to increase the amplitude of the message signal, it is slowly started to modulation, and at the demodulation section we can see the demodulated output of the message signal. Now let's compare let's see the output by putting capacitor in the output section. What will be the output? What will be changed in the output? See. By putting filter, we can see the demodulated signal of the amplitude modulated wave.